Good day, students. You are welcome back to our chemistry class. Today, we are going to continue on second class of Dalton's law of partial pressure. Just before we dive into this proper, if you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent contents. Now, from our previous classes, we are able to give us the definition or the law of Dalton's partial pressure. Today, we are going to move on the second phase of the calculation. Now, let us assume we have three gases. And these three gases, as you know, have pressures of P1, P2, and P3. Then the total pressure of these gases, P total of these gases, will be equals to P1 plus P2 plus P3. And don't forget that in a container that we have these three gases. Let us also assume that the amount of gases being confined in that container to be N1, N2, and N3. If we have N1, N2, and N3, then the total number of the amount of gases there also, total amount, will be N1 plus N2 plus N3. If you could recall as well from our mole concepts, you can as well go back to check the mole concepts. We proved about 6 formulae in calculating mole. One of them is that PV is equals to nRT. That's one of them. Where this N will equals to PV over RT, in which we are going to look at the calculation of this in our subsequent classes. Now, from here, our amounts, this one can be N1 to be equals to PV over P1V over what? RT. But what we need from here is our pressure, P, to be equals to nRT over V. So this one can be P1 equals to N1 over RT. Likewise, we can have P2 equals to N2 RT over V. Then our P3 will be equals to N3 RT over V. Now, from here now, you can come to this that P total equals to P1 plus P2 plus P3. Anywhere we find P1, P2, P3, we can insert all these values. But before we now proceed in this, we should also know that mole ratio, our mole ratio, that is N, will be equals to P1 over P total. Don't forget in our mathematics, if you want to get the ratio of something or in fraction, is going to be the number over total number. That is the number of pressure in this case over the total number of what? Of pressure. Now, this mole ratio, let's call it X1. Our mole ratio, X1. Now, from here, from P total, we can have P total. Let me use P to represent that total. We equal to our P1, and P1 here is N1 RT over V, N1 RT over V, plus our P2, which is N2 RT over V, N2 RT over V, plus P3, which is N3 RT over V, N3 RT over V. From here, let's find the SCM. The SCM of everything is V. V goes in V, we have 1. 1 multiplied by this, we have N1 RT plus this one, N2 RT plus N3 RT. Now from here, our P total will equals what is common in everything. We have RT is common, open brackets, N1 plus N2 plus N3, close the brackets, divided by V. Fine. That's our P total. to be equals to RT in brackets N1 plus N2 plus N3 over V. Now, from here now, you can now substitute these values into our mole ratio. So our mole ratio, or more importantly, we call it mole fraction. Our mole fraction, let's call it mole fraction, that is X1, will now equals to P1 over P total. So our P1, we have P1 divided by our P total is, don't forget, our P1 here is N1 RT over V. Let me remove this P1. N1 RT over V divided by my P total is RT in brackets N1 plus N2 plus N3 divided by V. So from here, our division will change to multiplication. Thereby, V will move up here and this numerator will come down. So X1 now equals to N1 RT divided by V multiplied by, since this division has changed to multiplication here, the V has to go up, divided by the numerator will come down, RT in bracket N1 plus N2 plus N3 in brackets. So V cancel V, R cancel R, T cancel T. So X1 will equals to, what next is N1 over N1 plus N2 plus N3. And don't forget, this one can mean X1 is equal to N1 over N total. N1 over what? N total. So this is our mole ratio. N1 is equals to X1, which is the mole fraction of the first gas, will equals to N1 over what? N total. And mole fraction also equals to what? This one can also equals to S1 equals to what? P1 over P total. So from here, X1 is equals to P1 over P total, cross multiply. Our P1 will equals to X1 multiplied by P total. Likewise, our P2 also equals to X2 multiplied by P total. Likewise, our P3 will equals to S3 multiplied by P total. But don't forget, your X1 will be equals to P1 over P total or N1 over N total. Likewise, your S2 will also equals to P2 over P total or N2 over N total, and your S3 will equals to P3 over P total or N3 over N total. Generally, we can have, as I explained here, X1 to be equals to N1 over N total. Or in terms of pressure, this can be equals to P1 over P total. Likewise, our S2 will equals to N2 over N total, also equals to P2 over P total. Then S3 will equals to N3 over N total, which also equals to P3 over P total. So from there, we now relate this. P1 to be equals to X1 times P total. So P1 will equals to X1 times P total. Example 1. A container contains 6 grams of gas A with a molar mass of 60 grams per mole and 10 grams of gas B with a molar mass of 50 grams per mole. If total pressure of gaseous mixture is 6 atmosphere, calculate the partial pressure of each gas. Now from here, we have, don't forget that we have our mass of gas A and the molar mass. To calculate each partial pressure, you should recall from our previous derivation that partial pressure of A will equals to the mole fraction of A multiplied by the total pressure. Now, our mole fraction of A is number of mole of A over total number of mole multiplied by P total. It's going to give our PA. well, definitely we are going to move to work on how to get our number of mole of A and the total number of mole. And to get our number of mole of A, if you could recall from your formula, one of your formulae of mole concepts that says amount N equals to mass over molar mass. So amount of A will equal to the mass of A given here is 6 grams, 6 divided by the molar mass given to be 60. When you divide, we have 0.1 mole for number of mole of A. For number of mole of gas B, that one will equals to the mass of gas B is 10 grams divided by 50, which gives 0.2 mole. From here, we can now calculate total number of mole to be equals to number of mole of gas A plus number of mole of gas B. Gas A is 0.1 plus 0.2 in moles. Now, this, when we add it up, we have 0.3 mole. Now, if you have 0.3 mole, we can then come to calculate the partial pressure of each of the gas, PA and PB. Partial pressure of A will equals to NA over N total times PT. Our NA that we got here is 0.1 divided by N total is 0.3 multiplied by the total partial pressure, and it is given as if total pressure of gaseous mixture is 6 atmosphere multiplied by 6. So when you take our calculator, multiply 0.1 times 6 and divide it by 0.3. This gives 2 atmosphere. That is for PA. Now for PB, PB will equals to MB over N total multiplied by P total. So from here, our PB will now equals to our number of mole of B is 0.2 divided by total is 0.3 multiplied by total partial pressure 6. So when you multiply 0.2 times 6 and divide it by 0.3, PB equals to 4 atmosphere. So that is the partial pressure of B. So when we add partial pressure of A to that of B, it gives us our total pressure here, which is what? 6 atmosphere. Example 2. A gaseous mixture contains 55% nitrogen, 20% oxygen, and 25% carbon dioxide by mass at a total pressure of 760 mm of mercury. Calculate the partial pressure of each gas. This is also similar to what we have learned in example 1. Let us get the total percentage of the gases. This percentage can also be converted to mass. That is, total mass will be 55 plus 20 plus 25, all in grams. When you sum it up, we have 100 grams. Fine. And number of mole of nitrogen will equals to the mass of nitrogen divided by molar mass of nitrogen. So to get the number of mole of nitrogen, it now equals to the mass of nitrogen, which is 55, divided by molar mass of nitrogen. Don't forget, atomic mass of nitrogen is 14. 14 multiplied by 2, we have 28. So when we divide, what do we have? We have 1.96 mole. Likewise, for the other gas, oxygen, number of mole of oxygen will equals to the mass of oxygen divided by molar mass of oxygen, which is equals to mass of oxygen here is 20 and molar mass of oxygen. Atomic mass of oxygen is 16 multiplied by 2, we have 32. So when we divide it, what do we have? We have 0.63 mole. Now move on to the last one, which is number of mole of carbon dioxide to be equals to mass of carbon dioxide divided by molar mass of carbon dioxide. The mass of carbon dioxide here is 25 grams. 25 over molar mass of carbon dioxide. Don't forget, atomic mass of carbon is 12. Oxygen is 16. 16 times 2, we have 32. 32 plus 12, so we are going to have 44. So 25 divided by 44. 0.57 mole. Now we are able to get the individual amounts. The next thing is to calculate the total number of mole, N total to be equals to the number of mole of nitrogen and that of oxygen plus that of carbon dioxide. Nitrogen 1.96, oxygen 0.63, carbon dioxide 0.57. Let us sum it up and tell me what we have. 3.16 mole. So this is the total number of mole. So we're now asked to calculate the partial pressure of each gas. Don't forget how to calculate the partial pressure. Partial pressure of nitrogen will equals to mole fraction of nitrogen multiplied with total partial pressure. And you know your mole fraction to be equals to number of mole of nitrogen over total number of mole multiplied by the total partial pressure. Partial pressure of nitrogen equals to number of mole of nitrogen over total number of mole multiplied by total pressure. So number of mole of nitrogen that we have here is 1.96 divided by 3.16 multiplied by total pressure that we are given here is 760. So we multiply the numerator and divide it by this denominator. 471.4 millimeter of mercury for the nitrogen. Now, for the oxygen, it's going to be number of mole of oxygen as well over total number of mole times total pressure. Number of mole of oxygen there 0.63 divided by 3.16 multiplied by total pressure 760. So what do we have here as well? 151.5 millimeter of mercury. So the last one is to now get the partial pressure of carbon dioxide. Partial pressure of carbon dioxide also equals to number of carbon dioxide divided by total number multiplied by P total. Number of carbon dioxide that we got 0.57 divided by 3.16 multiplied by 760. What do we have here as well? We have 137.1 millimeter of mercury. So these are the ways of calculating partial pressure of individual gases. Example 3. At constant temperature, 250 centimeter cube of nitrogen at a pressure of 740 millimeter of mercury and 308 centimeter cube of oxygen at a pressure of 700 millimeter of mercury is filled in 1 DMQ flask. 1 DMQ flask. Calculate the partial pressure and total pressure of each gas. From here, if you look at this at constant temperature, it's given us the idea of one of the gas law, which is Boyle's law, which is at a constant temperature. Now for nitrogen, volume of nitrogen, let's say V1 for nitrogen equals to 250 centimeter cube, and the pressure P1 for that nitrogen equals to 740 millimeter of mercury. Now from here, our P2, okay, let me say V2 of nitrogen is this 1 dm cube. You know, they occupy 1 dm cube flask, which is 1,000 1 dm cube, 1,000 centimeter cube. So our P2 of nitrogen is what we have to look for, which is our partial pressure. From P1 V1 equals to P2 V2. we have to look for P2 here. My P2 will equals to P1V1 over V2. So I have my P1 here is 640 multiplied by our V1 250 divided by my V2 is 1000. So let us multiply and divide by 1000. 160, we have 160. That is our pressure, and our pressure here is in millimeter of mercury. That is the partial pressure of nitrogen. Now, let's calculate for that oxygen. From here as well, 380 centimeter cube of oxygen, V1 for oxygen, 380 centimeter cube, at a pressure of 700 millimeter of mercury, P1 of oxygen, 700 millimeter of mercury. Now don't forget our V2 of oxygen remain constant, 1000 centimeter cube. That is in 1 dm cube flask. While our P2 of oxygen is unknown. That is what we are told to find. And P1 V1 equals to P2 V2. From here, my P2 will equals to P1 V1 over V2. So when we introduce this, we have P2 to be equals to, my P1 here is 700 multiplied by my V1 380 divided by my V2 is 1000. So when you multiply and divide, what are we going to have? We have 266 millimeter of mercury. So our P2 of oxygen is this. So we are able to get partial pressure of nitrogen and partial pressure of oxygen. Now, let's find the total pressure. You know, total pressure will be the addition of the first gas and the second gas. P total will equals to P of nitrogen plus P of oxygen. That is P of nitrogen 160 plus 266. So we have 426 millimeter of mercury. That's our P total. So my dear students, if you find values in this class, kindly subscribe to my channel and click the notification bell for my subsequent class. And don't forget to share so that other members can benefit. We are going to move forward in this gas law in our subsequent classes. Thank you and God bless you.